This demo is on color selection. In particular, you will take a picture generated in the Gaggle Illustrator, and we will modify the colors in it using an interfacing tool called Color Glue, which bridges the Gaggle Illustrator to the Meta Palette. The Meta Palette allows us to edit a palette by moving around points in a chromaticity diagram. The theory behind the tool is based on colorimetry. Let's see how this works on the monitor. The metaphor used in the Color Glue to bridge the Meta Palette with the Gaggle Illustrator is that of immersing the picture in turpentine. So the colors will soften up and we can edit them. So we type the command turpentine and then the Gaggle file name. We can take, for instance, the gumball machine, and we obtain a window that shows a chromaticity diagram with a point for every color that appears in the original Gaggle picture that we see here on the color viewer, on the color monitor. Since it's not easy to find the correspondence between points and objects by just looking at the chromaticity diagram, especially in the case like here where two colors are very close, we can select the point in the chromaticity diagram and all the corresponding objects in these colors will flash in the Gaggle picture. To change the color of an object, once we have found which the object is, we simply take the point in the chromaticity diagram, for instance here the yellow, and move it to the chromaticity of the colors in which we want to have it. We can also change the lightness of a color. We can make it lighter or we can make it darker. The chromaticity changes slightly because the values can be outside the gamut of the monitor. We can use either the metric chromaticity diagram, which is corresponds to a uniform color space, or we can use others such as the more traditional 1931 CIE chromaticity diagram, or we can do the editing in a cross-section of the CIE lab space. We can also display a histogram of the lightness values of all the colors in the palette. So we go from the darkest values on the left side up to the lightest values. And we can edit these points in the lightness space exactly as we can edit the points in the chromaticity diagram. If you have enough real estate space on the color monitor, this means if you use a high resolution display, you can display also the chromaticity diagram on the color monitor, and it will be easier to recognize the different points because we see also their color. And if we move a point, like for instance the orange point, and we make it like before purple, you see that it has become purple. You can zoom in and see it is purple. Now back to our original uniform chromaticity space diagram. The outer curve here represents all the points that can of correspondence to colors that exist in nature. Obviously, on a physical device, we cannot reproduce all these colors. In the case of a color monitor, we can reproduce only the colors that are inside this triangle. If we print this image, then the colors that fall outside the gamut of the printer will be distorted. It's an open scientific problem how to modify the colors that are outside a printer gamut in a way that looks natural for a picture. What we do in the meta palette to make the work easier for the graphical artist is that we allow him to superimpose the gamut, the shape of the gamut of various printing devices, like for instance, in this case, that of a thermal transfer printer. The user can now decide on his own where exactly, for instance, he wants to move this out of gamut green. He can simply move it, for instance, on the edge of the gamut. Or he could decide to slightly modify its chromaticity towards the yellow because it would fit better the general aspect of the image. There is a number of printers for which we have the gamut shape. This was the thermal transfer printer. This is an electrostatic plotter. And this is the gamut that we obtain in a typical offset process. Now, once the colors are inside the gamut, the use of the Xerox color encoding standard guarantees us that the colors inside the gamut will be reproduced correctly. Unfortunately, not everybody has a color-corrected, calibrated printer. In this case, we can preview what the colors will look like on an uncalibrated printer. So for this offset gamut, we can ask the printer how would the colors be changed on this printer if it would not be calibrated. And accordingly to the movement of the chromaticity points here in the diagram, we see that the colors changed on the color screen. And we can repeat this for our other printers, like for instance the electrostatic plotter, the thermal transfer printer, or we can even superimpose the effect on different monitors. For instance, this is the gamut of an NTSC monitor, and this is how the colors would change on an NTSC monitor. Once we are finished with the editing, we apply digital fixative to the image. The effect of applying digital fixative restores the original gargoyle data structures, and we will be able to do our normal editing and printing with the image.